Hey guys, so here's part 4 of the 2.4 day 1 notes. So these are going to be the last bit of notes. These are just more ways that we can factor polynomials expressions, okay? Now these are going to be kind of looking similar to when we had quadratics. It's just we're going to have larger exponents here. Okay, so we have example 4a, we got 16x to the 4th minus 81. Now, anytime we are going to factor, don't forget, because these are polynomials, see if the two terms have anything in common. So if we look at a, do these two terms have anything in common? No, they do not. So how we're going to factor this is we're going to treat this like if it was a difference of two squares. So we're going to do two sets of parentheses, okay? Notice that 16 and 81, they are perfect squares. What's the square root of 16? That's going to be 4, right? Now, this is where it changes. Usually when we do the difference of squares, right, we have 4x and 4x. But because we have to multiply to x to the 4th, this is actually going to be x squared, okay? That's the only difference between this problem and a difference of two squares type of problem. Instead of having just x, we're going to have x squared. Okay, 81, that is a perfect square. We know it's 9. And don't forget, because we have the subtraction, we're going to do a plus and minus. Now our last thing that we need to talk about is factoring even more here, okay? So notice that we have 4x squared plus 9 and 4x squared minus 9. Now when we factor, we really only just want real numbers. So we could do 4x squared plus 9 when we factor, but that's going to give us complex solutions. And we're not really caring for doing complex solutions right now. We just want real factors. So that means the 4x squared minus 9, we can actually still factor that because now that one is a difference of two squares. So I'm going to bring down my 4x squared plus 9 and then factor 4x squared minus 9 even more. So remember, you got to factor completely. Anytime you see a squared or anything that is not linear, see if you can factor it a little bit more. So 4 and 9 are perfect squares. Square root of 4 is 2. Here we're going to do 2x and 2x because that'll give us the square. And then square root of 9 is 3. I'm going to have a plus and a minus. Now we got that down to a linear, so we can't factor it anymore. This will be our final solution here. Okay, let's go ahead and do part B here. Now, part B is going to kind of be similar to if this was already a squared, okay? Now, the very first thing you should always ask yourself is, do these terms have anything in common? In fact, these do. They all three have a 2 and a p squared in common. Now, I'm going to rewrite this. I have p to the 6. Because remember, we're basically dividing those bases, so we subtract the exponents. And I get plus 5p to the 3rd, and then plus 6. Now, what's inside the parentheses, we're going to treat this like if it was a quadratic. So we're basically going to do just the two sets of parentheses to allow us to factor. Now, don't forget to bring down the 2p squared for my two sets of parentheses. Okay, now how we're going to do p to the 6th? Well, that's just going to be p to the 3rd and p to the 3rd. And the reason being is that, remember, if we have the base, same base, and we multiply, we add the exponent. So 3 plus 3 will give us that 6. Now for 6, we know we have 1 and 6, 2 and 3. Which pair will add up to the 5 in the middle? That's going to be our 2 and 3. So I'm going to have basically plus 2 and plus 3. Okay? Now, because we have this cube, we could talk about difference and sum of cubes. Okay, but if we look at the number 2 and number 3, are those perfect cubes? No, they're not. So we actually cannot factor the p cubed plus 2 and the p cubed plus 3 anymore. So this would just be our final factorization. Okay, so now what I would like you to do is go ahead, pause the video, and factor part C and part D. Okay, so you're doing both of those, part C and part D. So pause the video to do so. Okay, let's see what you got here. So x to the 4th minus 16. So we have this. We know we're going to treat it similar to a difference of squares. We're going to do our two sets of parentheses. Okay, so we know the a value is 1. So we're going to have x squared and x squared. Square root of 16 is 4. I'll have a plus and minus. Remember, when we're factoring, we want actually just real factors, no imaginary. So though we could factor x squared plus 4, that would give us complex, and we don't want that for right now. So I'm just going to bring it down. But if we look at x squared minus 4, that is a difference of squares, okay? So we're going to factor that just a tiny bit more. So we're going to put x in x, and then square root of 4 is 2. We add, and then we subtract. And then we can't factor anymore, so this will be our final factorization. So remember, you know when you're kind of done factoring, especially when you have linear. If you ever have quadratic or you have cubic, definitely see if you can factor a little bit more. Sometimes you can, sometimes you can't. Okay, now let's look at this. We got 256y to the 4th and minus 81. Okay, so now we got to figure out, do these two terms have anything in common? Actually, they do not. So if you tried, they do not. If we look at 256, it's not a perfect square. Actually, in fact, it is. The square root of 256 is 16. So if you don't know, just plug it into your calculator. Do square root of 256, and then you should have gotten 16. So we're going to treat this like if it was a difference of two squares, okay? So I'm going to create my two parentheses here. Square root of 256 is 16. And don't forget here, because we have y to the 4th, we have to have squares, okay? And then 81 is a perfect square. We know it's 9, so I'm going to have a plus 9 and minus 9. Now, another way of saying this is, and you'll probably hear if just hearing in the lesson, maybe difference of squares in disguise. So that's kind of like A, C, and D. So that's kind of another way of saying them, that they are difference of squares in disguise. Okay, let's see if we can factor any more. Now, 16y squared plus 9, we could, but that's going to give us complex, and we don't really want that, so we're just going to keep as it is. However, on the other one, that is a difference of two squares, because 16 and 9 are perfect squares. So we're going to go ahead and factor that, so we get 4y minus 3 and 4y plus 3. And because those are linear, that means we can't factor it anymore, so this would be our final factorization. Okay, make sure if you have any questions, you contact me, and make sure you work on the homework assignment. See you guys later.